Hello, thank you. Well, as the intro said, my name's Sharon Woods. I work for the Qt Company Professional Services. If you haven't heard of us, we're the consulting wing of the Qt Company. We help out customers from everything from a few hours of training to full development projects. And in the midst of one of these projects, I started using Shiboken to access the functionality of existing C++ libraries from a Qt for Python application. So this proved very useful. The documentation, as Christian mentioned, needs a little love. And so I wanted to give you an overview of how we did that and hope that you could try to do the same yourself. So what is Shiboken? Well, we've already gone over it in the last talk, but I'll just review it real quick. It's the Python binding generator used to create the PySide module of Qt for Python. In other words, it's a system that is used to expose the Qt C++ API to Python. For many Qt for Python users, it's totally transparent to them. They use pip install to install Qt for Python, utilize Python and Qt, and are completely happy. But there's some cases where you may want to use Shiboken to access existing C++ libraries. So what's some possible scenarios that you would be needing Shiboken? You could be that you have an existing C++ library that you want to use from Qt for Python. This library could be proprietary, or it could just be something that's been well tested, well used. You don't want to rewrite it all in Python. You just want to use certain functionality from it. Another thing is that you're a seasoned Qt developer who's developed all these great tools using Qt, and you don't want to rewrite those in Qt for Python, and so you want to access that. Another thing is you might want to use some third-party. Like for instance, one of the examples I'm going over today is a third-party open source Qt-derived library that we exposed using Shiboken. And the last one is that you're switching to Qt for Python from another wrapper, i.e. probably PyQt, which, as Christian mentioned, has its own binding generator called SIP. If you're not using some of the tools out there that allow you to combine PyQt and PySide 2, and you use SIP to access C++, you're going to have to rewrite those bindings with Shiboken if you're going to go pure Qt for Python. Is Shiboken the only answer? Again, Christian covered this pretty thoroughly. No, of course not. There's plenty of other generators over there. He had a nice review in the last talk about some of the benefits of them. If you've been using them, there's nothing to stop you from using them again. But Shiboken could be the choice for you, especially if you're generating bindings that are on C++ that's already using Qt. It's also already installed if you're using Qt for Python. So great, you say. How do I use it? But before I get started, I just want to do a brief note on nomenclature. When I refer to Shiboken, I'm referring to Shiboken 2, which corresponds to PySide 2, which is the version of Qt for Python that was released in 2018 for Qt 5. The 2 was to differentiate it from the original PySide and Shiboken that was back released by Nokia in 2009 for Qt 4. This 2 has caused some confusion, especially since Qt for Python has its own versions that correspond to the Qt release schedule, 5.13.1, etc. So it's a little confusing, and needless to say, when Qt 6 comes out, everything's going to go over to 6s to make it a little bit clearer. But just in the meantime, whenever I mention Shiboken or PySide, I'm referring to the 2 versions. Okay, so to get started, you're going to need all the same things that you do for Qt for Python. A version of Python, a 5.12 plus version of Qt, libclang, cmake, and then you need to install Shiboken. You can install it with pip or build Qt for Python from source. The latter is recommended but not required for reasons I'll go over in the next couple of slides. Okay, so I had mentioned a little bit earlier that if you already have Qt for Python, you have at least a partial installation of Shiboken. And the reason why it could be partial is if you use the nice Pythonic clean pip install PySide 2. If you do a pip list after that, you'll see that you have a version of the PySide 2 module and Shiboken 2. What you don't have is the binary Shiboken 2 generator. which we do need to generate our own bindings. To get that, you do have the option of using pip install. You have to get the wheel from the Qt servers, and you have to make sure that you have not only the right operating system, but that you have the same version. You can install it this way if you don't want to build the source code yourself. If you do this, you have to keep in mind that the wheel, you can't include symbolic links within it, so you have to do a few additional steps to get it to work. Here, I listed the free steps here. I've gotten it to work this way on Linux and Mac OS. This is the nice, cleaner way to do it, but I do recommend you try building from source. Even if you don't build from source, I do recommend you get the source code because I reference the source code quite a bit in the rest of this talk. So there's a lot of good information in here. So even if you go the pip install route, you can do it here. The directions for getting the Qt for Python source is very nicely explained on the wiki page. I included the link there. And then it consists of the PySide setup directory. I highlighted a couple of the directories here that you might want to take a look at as resources. So I mentioned that there's a lot of reference material in there. I'm going to be referencing things from those two directories in the rest of this talk. Okay, so now let's say you've got Shiboken installed. What are you going to have to do to generate your own bindings? It boils down to you have to create three things. The first thing, of course, is a Cmakelist, and that basically does, if you've used Cmake, that is basically what for Cmake. It's basically the directions for the whole build process to create your binding module that you'll be creating. The other two elements are two files, a list of the C++ library headers that you want to wrap, and a type system file, which is an XML format. I gave the guys the names binding.h, bindings.xml. These are the same names that I'll use throughout the examples in the rest of the talk. So how do these fit into that process that Christian explained in the last one? So Shiboken uses Clang to look at that bindings.h file to extract the API of the C++ that is going to be binding. And then it uses the directions that are in the type system file to add any of the modifications, the ownership, anything that you need to do in regards to how you're going to get Python and C++ to talk to one another. And it generates the wrapper code in C Python there, which can be created into your generated Python module. Okay. So I mentioned that under the examples, there's a sample binding example that I've listed the contents here. And if you do nothing else from the source code, I would take a look at this thing because it's a great starting point. Everything I'm talking about right here, we started with this as our little boilerplate. And you'll see, if you look in it, that it has those three files that I mentioned. And it's described in great detail in its README. And there was also a blog post, some of you probably have read it, that it goes over this. Okay, so I'm going to go over a couple of examples. The first example is a simple graphing example that demonstrates accessing the functionality of a C++ library from a Qt for Python graphical application. So this is a pure C++ library that did not have any Qt in it. The second example is a much more realistic one, which was produced from the Qt Professional Services for a customer. And that was the Python bindings for QWT. This is a pretty well-regarded scientific graphical library based on Qt widgets. And we created a binding so that we could access QWT from our Qt for Python application. So let's move on to the first example. This is admittedly a very contrived setup for the following scenario. Say that you're an analyst who's really comfortable working in Python. You like to use NumPy and SciPy for all your mathematical things. You don't want to deal with that. But you've inherited this legacy C++ library. It's the one that talks to your hardware, extracts the data, and actually has some function that was written by someone who left the company 10 years ago that fits the data. So you need to access not only this C++ library's ability to extract the data, but also its fitting. It also has a data that it fits to your generated data. And you're saying, I can do better than this old library. So you've created this. This is a Qt for Python application written with using Qt charts and QML. Just a note, I don't have time to show all the code or everything. At the end of the talk, I'm going to provide links so you can download this repository if you want to look at the code of these examples in full. So we have our Qt for Python application, and then these two buttons in the lower left here is how we're going to be accessing our C++ library. So you're going to get the data from it. When that button's pressed, we're going to use the fit that the C++ library used, and then this button is only going to do it's purely for the Python side. That's your SciPy generated fit, which is going to be much better. And let me just play back of the example. So here's our data from the C++ library. I told you this was a contrived example. So the C++ library just does a linear fit. And you can do much better with SciPy. In a single line, you can create a nice nonlinear fit that looks much better. So here's all the files of the simple graphics example. As you can see, we have the 3 files I mentioned before. And the files in blue is the entire Qt for Python application, which is just one Python script and the QML for the layout of the graphics. There is a couple of other things here. This setup here is just a shell script with all the cmake commands, which is based on the sample bindings README file. And then another thing that I grabbed from the source code, PySide 2 configs. This has helped me out in the Cmakelist, creating paths and links to the appropriate libraries. Okay, so here is some of the, actually, let me go back one. Oh, okay. Now, one thing that's kind of unrealistic about this example is that the C++ library you are is being built as part of the process. Everything's in one directory, but it's an example. This C++ library only has three classes, and you'll see they correspond to those buttons on it. There's one that's the data fitter and the data generator. I also included a third class that we don't care about. This third class is used by data generator, but we don't need it in Python at all. And the reason I brought this in here was because I wanted to show that when you're binding a library, you don't have to bind everything. You can just extract a certain subset of the functionality. And that's all you have to do. You can ignore the rest of the C++ library. Okay, so here's data generator, and as I mentioned before, there is that function there that get data. That's the one where we got our Y data for that plot. And then there's also another public thing that uses that internal class that we want to ignore. And here is data fitter. This one, we just have that linear regression function that provided that archaic fit to the data. Okay, so moving on to our 3 files that we want to generate. This is the Cmakelist file for the simple graphics. Now, I'm going to scroll through it, and as you can see, it's pretty lengthy. But I just wanted to point out that I actually only changed 8 lines of this from the sample binding example. The sample binding provides a Cmakelist file that has great comments and that you can read through, and is a great starting point. So that's my advice to you, is you start with the sample binding example that comes in the source code, and you can start learning on that, and as you master things and gets better, you can get more complicated as you go. So this is just a quick look at the 8 lines I changed. Pretty straightforward stuff. The name of the project, the name of the library I'm building, and the name of the module. You have to list out the generated wrappers that you're going to be producing. So those names are changed from the sample binding. And then also I changed the location of that PySide 2 config script. So that's it. That's the only thing I changed on Cmakelist from the original example. Here's our bindings.h file. As mentioned, I only care about data fitter and data generator. I don't care about internal class, so I only list those two. So let's go on to the more interesting part, the type system file. This is just the first few lines here. First thing is we provide the name of the module that we are going to be building. This will be what we import into our PySide, our Python script to use. The next thing we want to do is we define a primitive type. And this is which C++ primitive types we're going to use. And we want to provide this so that Python knows how to deal with them. So this is available for, int, bool, etc., all these ones. For this example, I just needed double. So that's why that's in here. Then I define either object types or value types for the classes that I want to generate bindings for. Now you notice that I put in here internal class. We didn't really care about that. So I have added this command here saying, no, I don't really want to generate any bindings for that. I actually don't really need this line per se because I didn't list internal class in bindings.h, but putting this line in removes a whole bunch of warnings because internal class is referenced elsewhere in the library. And then I have these two types here, data generator and data fitter. Now you remember data generator, when you list a class in the type system file, Shiboken is going to try to create bindings for all the public functions of that class. So if you don't want one in there, you can remove it here. So I don't really care about that internal class, and I remove that one. And then data fitter there, we wanted everything, so we put it in there. I also designate whether or not it's a value type or an object type. What's that mean? That's just saying that within the C++ code, is it handled by pointers, or is it passed around as a pointers, or is it copied? Okay, now moving on to the second half. And I don't want you guys to get too scared by me putting this up here, because what I'm doing here is I'm creating a couple of templates to handle how to translate the C++ vectors into PySide sequences and vice versa. And the reason that these templates were created was that we need to create a container type because this library passes data back and forth using standard vectors. And now, as you can see, this is a little bit more involved code within the type system file. And before you get too worried about, oh man, I'm gonna have to learn all this, I don't know about this. I just want to say you probably don't have to. And the reason why is there was a lot of work done in type system files to create PySide 2. And you can use that as a resource. So I will show you later that all this, pretty much all this, these lines I showed you here were just grabbed directly from the source code for PySide 2. Okay, so you've created your 3 files. You're all set to go. I just wanted to show you. Here's me building the my module for the simple graphics. So you see it builds the library, creates the wrappers, and at the end I put in a little bit of creating a nice little package so we could load it into the Python script. I'm not showing the whole Python script, just the parts that are pertinent to what we want to do. Here we are from the beginning. We've created our new module, DataFit. We are importing those 2 classes that we're interested in, data generator and data fitter. And then down in the lower left, this is the Python script code that's generated from pushing that get data from C++. So we create an instance of data generator, and we get the data. There's that function, that public function we wanted. And the same thing over here for the fitting. We create an instance of the data fitter, and then we are able to access that linear regression function. Okay, so moving on to that more realistic example. This was the work of several people. Actually, several of them are in this room, and several people at professional services. We had a customer who had some very specific graphical needs, scientific graphical needs, but they wanted to have everything from Python. So they wanted, and the reason that they were reusing Python was that they provided a tool that they allowed their customers to alter the scripts as they needed it. And they just felt that it would be more nice to have a scripting tool rather than a C++ tool for this. So we needed to wrap QWT. QWT is an open source. I think probably many of you know of it. It's been around for quite some time. It's pretty well known. Okay, so here's the PySide Cmakelist file is a little bit more different than the last one. Even though sample binding, the baseline was used again, there was a few more differences on this. QWT is more realistic. The library is already built and elsewhere. So we've removed all that stuff in Cmakelist that was building that library and created the link so that we could find it. There's a much longer list of C++ classes that we're going to be generating wrappers for because QWT is much bigger. And then most notably is since QWT already uses Qt widgets, we added changes to allow Shiboken to access PySide 2 type system files. In other words, we're reusing the work that was already done to generate PySide 2 to create the bindings of the Qt modules that QWT is using. Okay, so here's the bindings.h file. Anybody in here who might be familiar with QWT might notice that we don't have all the contents of QWT in here. This was just the ones that we needed for this particular project. We put the Qt Professional Services put this group out on a public repository. So if you happen to use it and you need to expand it, feel free to submit changes to it. We welcome anybody who would want to use it. Okay, so let me see. Oh, I've only got a couple minutes. So I'm just going to touch on a couple of things on the type system file. So the first 3 lines here, we use a command called load type system. And this is what I was talking about earlier, is that what this allows us to do is to reuse the type system files that were used to generate PySide 2. We're loading them, but we're not regenerating them. And this gives us all the capabilities that were created for PySide 2 and Qt, so we can reuse them. Where are all these type system files that I keep on referring to that are great resources? They're in this directory here of the source code, and each of these bolded directories here contains type system below it that correspond to the Qt module that they're wrapping. There's also some great stuff under glue and templates. And as you said, as I mentioned, like if you remember from the last slide, I was loading type system core common. That is under the, as you no surprise, the Qt core. Templates there I got that those templates that I used in the last example. Does this look familiar? This is directly from the core common templates folder, and that provided that vector to PySide sequence and vice versa. And I even grabbed the container type from Qt core, type system core. Does this look familiar? There's actually one small difference here in that this container type is actually creating the container type for Q vector, and that simple example from the graphic example was just using standard vector. But that's the only change here. So this is the core of what I wanted to get across, in that maybe why Shiboken might be the right choice for you for binding, is that there was a whole bunch of great work that's available that you can reuse from the PySide 2. Let me see. And then one more thing from the bindings, the type system file, was that Shiboken does not have the ability to wrap templated classes. And one of the key things that we had on the QWT that we needed to use, we wanted to use QWT plot curve, which inherited from an explicit instantiation of QWT series store, a templated class. And this held us up a little bit until what we did was we explicitly said, do not generate the bindings for QWT series store data here. And this allowed us to create a bindings for QWT plot curve, which we used in our script here. Here that we create, well, actually this next one that has the plot curve, but this is some of our Python code. There's some examples provided in PySide QWT, and you can see here that we're setting up this example here that's just kind of a silly, this was to exercise all the stuff that our specific customer needed. And so that's why it's kind of an odd plot. but you can see here we created our axes, named them, and then in the next slide, this part of the thing, this is where we use QWT plot curve, and we used NumPy to generate some random data and plot it. So in conclusion, there's several candidates for creating your bindings. You don't necessarily have to Shiboken, but it's worth considering, especially if you're already using Qt for Python, and if you're trying to wrap a library that's already using Qt. The other thing is that Shiboken is constantly evolving and improving, and it's expected that some of the difficulties of setting it up that I've shown here and to generate the bindings will be fixed. And as Christian mentioned, it's going to get some more love on the documentation side. Okay, so as promised, here is the links to the repositories and also some helpful resources. Thanks for listening, and I hope, oh yeah, all right, I'm already getting questions, okay. Sure, yeah. Yeah. I do not know. Do you? Yeah. Oh, you no. Yeah. Oh.
Two questions. First question is the license of Shiboken and the code that is generated. Could we use it in the, for example, closed source products, or we could have a licensed Qt, how to deal with this? And the second question is, if this tool works so good, why don't Qt provide the second language, Python, as a main language for the library?
I don't know if I have the answer to that one. In regards to your licensing question, it's the LGB3 version 3. That's the same.
The tool itself or the code that is produced?
The tool itself.
Okay.
Yeah.
The code is produced, it goes under which license?
I'm not a lawyer, but it should be under the same thing that you're using the code space, right? That means you C++ libraries have some license and you generate some drivers or Python.
In this case, it's not obvious why it's algebra, because it's like a library. Shiboken is a library. It's a tool.
There's some disconcerting commentary on the PySide 2 Shiboken pack that says you can distribute closed source bindings if it was generated from LGPL code in the first place, LGPL Qt in the first place. I found it confusing, also not a lawyer.
Yeah. Yeah, that's my answer too. I'm not a lawyer, so I hesitate, especially since I'm being recorded. So, yeah.
In this case, so if there are many Python software engineers, yeah, this it looks like the majority of the functions of the Qt library could be binded to the Python. Why not provide it as a major tool, for example, in the Qt creator to create a Qt applications with Python?
Actually, that is one of the things that they're working on, is to integrate it more clearly into Qt Creator. So.
Yeah, we have looked at some kind of the roadmap for Qt 6, but there will be Python, but it's not declared as, we will have another language that will lead to the development of Qt 6, for example, or Qt 7. There are no surveys. This is my question for you.
Well, mainly from the keynote talks, I think they made a point that we didn't want to cover it because we have many talks. But the idea is to give Python this category of first-class citizen at some point. But as long as you mentioned, we have to work towards that, and still we are dealing with complexity. For example, for 5.14, one of the next feature that now it's completely compatible on the Qt side. So that we are little by little trying to make everything compatible with Python.
And what blockers do you see? Do you see now, for example, if we will say, okay, tomorrow we will ship the plain library, all functions of Qt, so all Qt modules with the Python. What blockers do you see?
Well, yeah, there are many things there. I mean, you need to, again, deal if it's really worth it to expose some certain models because maybe something exists in Python, and then you need to make everything compatible with that model that you are including, so you need to kind of draw a line there. I think it's a complicated question. I don't know if I can give you like the answer of it. It really depends on the conditions.
And what about memory consumption and performance? Because you're ripping something, that means you lose at some point. Have you some?
We don't have the numbers, but we should totally use it.
All right. Oh, did you have a question? Yeah.
Real basic question on mechanics. If I understood correctly, the auto generation stops before you get to the XML. I have to sit and generate XML by hand in an editor, notwithstanding being able to
Yeah.
borrow from the
Yeah.
website.
Yeah. But as I was trying to say, I just glommed everything from PySide too. So
If there is no question, thanks, Sharon.
yeah, thank you.